Okay, guys, I hope you're doing great. In this video, I'm going to talk about how to find area under a curve. I'm going to consider three cases to practice. This is one of the last topics you learn in your course. So it's something that many of you struggle. And hopefully at the end of this video, you're going to have a better understanding of these kind of questions. Uh, what does it mean finding area under a curve? So a function is given to you. Let's see, for example, here, a function is given, this function here, okay? I'm asking you, go and find the area bounded between x equals to maybe 3 and x equals to 10, the x-axis, and the function which is given to you, okay? So this is what we're going to practice in this video. We're going to find this area. There are three different cases. Case number one, we're going to find the exact area with the calculator. I'm going to tell you two ways to do it, okay? Then I want to tell you how to find the approximated area using trapezoidal rule with unequal subintervals. And we're going to do the same question, this time with equal subintervals for the third case. In both cases, I'm going to go and find percentage error as well. Okay, I think it's going to be a good question to practice. So let's read the question. Let f of x be x equals to the power of 3, x to the power of 3 for x between 1 to 11. So this is your domain in this question. Your domain is x, all the x values between 1 to 11. Okay, the region R is bounded by the curve y equals to f of x, the x-axis, and the lines x equals to 1 and x equals to 11. Find the exact area of R using your GDC. Give your answer to 3 significant figures. Okay, not 6. 3 is enough. Okay, so what is your function? This is your function. You don't need to know how to graph it. You can use your calculator, okay? X from 1 to 11. We're going to find this area. So this is y equals to x to the power of 3, this function here. Okay, we're going to find this area together. How? Two methods to use with calculator. Menu, file, new document. Okay, so I'm going to go and add calculator. Menu, calculus, numerical integral. You're going to put the intervals, which is from 1 to 11, x equals to 1 and x equals to 11. What is your function? X to the power of 3. And here you're going to put dx. Okay, this is the way to put it into the calculator. Okay, you're going to put your function and you're going to put the x values. So x from 1 to 11, press enter, 3660. So this is the exact area. The exact area equals to 3660 unit to the power of 2. Okay, what is the second method? Let me do it for you. You don't need to learn it, but I think it can be very helpful also to learn how to find the area in this way. Add graphs. We're going to do it graphically. Put your function x to the power of 3. So I'm going to go and say menu. I'm going to do this menu, analyze graph, integral. I'm going to put 1 here, enter. And next time I'm going to put 11 and enter. Okay, now I have the area 3660, which is exactly the same thing. Okay, so we know how to find the exact area under a given function, the curve, with this method, with the calculator. Nothing particular about that. So what is the formula just to practice? Area equals to, the exact area equals to integral from 1, in this case to 11, your function x to the power of 3 times dx. Okay, this is your input dx. Okay, now let's talk about the second case. Now I'm going to approximate the area. Okay, so I'm not going to use calculator. I have to use trapezoidal rule. What is trapezoidal rule? So how can I find the area of a trapezoid? It's just prior knowledge. Okay, the area of a trapezoid has a formula. What is the formula? This area here for a trapezoid equals to a plus b divided by a plus b times h divided by 2. This is the formula for area of a trapezoid, this area here. Okay, Now, we're going to use this formula to find an approximation for the area that we are interested to find, area under the curve in this case. So what is my function? One more time. This is my function, okay? This is x equals to 1, and this is x equals to 11. The question this time is telling us estimate the area of R using the trapezoidal rule with x equals to 1, 3, 6, and 11. So these values are given to you. Now, we're going to use trapezoidal rule. Do you agree with me if I connect these 2 points to each other, I'm going to have a trapezoid here? Okay. Do you agree with me or not? Section 1. This is section 2, and this is section 3. Can we go and find the area of section 1 together? Area of section 1 equals to, so this measure here, let me choose another color. This measure here is the y value of this point, right? Point 0, I'm going to call it point 0, point 1, point 2, and point 3. So the y value of point 0 is 1 to the power of 3 plus, do you agree with me, this measure here, which is the b, is 3 to the power of 3 times, what is your h in this case? H is 3 minus 1. The x value here is 3, here is 1. 3 minus 1 is 2, divided by 2. So this is the area for the first section. Now, can I go and find the area for the second section? Maybe you can pause the video and do it on your own. 3 to the power of 3 plus 6 to the power of 3 times, this time 6 minus 3, which is 3 units, divided by 2. And what about the area of section number 3? It's 6 to the power of 3 plus 11 to the power of 3 times, this time 11 minus 6, which is 5, divided by 2. Remember, this is section 2 and this is section 3. So in section 3, I'm finding this value here. And in section 2, I'm finding this value here, okay? And in section 1, I found this value here. Okay, so as you can see, the area I'm calculating is not very precise. Why? Because I'm also calculating this red part here, or purple, this section here, which is not under the curve, but I'm including in the area of section 3. So that's why we call it an approximation. Okay, it's not very precise. If you add up all these 3 values, you're going to end up to 44,000. These 3 values here, 3 fractions, 4,260 unit to the power of 2. Okay, so as you can see, the area that we have found here is bigger, and that makes sense because we are overestimating. Can we find the percentage error for case number 2? So we're going to find the percentage error. It's 4,260 minus 3,660 divided by 3,660. You have to put the exact value. Don't make a mistake here. Times 100. This is going to give you the percentage error. Do I have it here? Yes or no? No. So control division, 4,260 minus 3,660 divided by 3,660 times 100 times 100. Control enter. 16.4 is the percentage error in this case. That's it. One other thing, sometimes they don't give you the function, they give you the points. What does it mean? So remember, in some questions, they don't give you the function, they give you the points. They tell you x, y. So x is 1, x is 3, x can be 6, and x can be 11. When it's 1, the y value is 1. When 3, the y value is 27, 6 to the power of 3, 216, and 11 to the power of 3. Okay? If they give you the table, it's literally the same thing. Area of the first section This is the area of the first section, which you have it here. This is the area of the second section, which you have it here. And this is the area of the third section, which you have it here. Okay, that's it. Now, let's do the same question with equal subintervals. What does it mean? This is my curve. This is x equals to 1, and this is x equals to 11. Subintervals. Let's read the question. Estimate the area of R using the trapezoidal rule with 5 equal subintervals of width 2. So 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. These are my subintervals right now, and they are equal to each other. They are all 2 units, all these subintervals. In this case, our job is a little easier because we have a formula on your formula booklet. I'm pretty sure many of you struggle to understand what is this formula about. Okay, we're going to practice it in this question. So in this case, the approximated area equals to h divided by 2. What is h? H is 11 minus the first value 1, the x value of the first point 1, divided by the number of subintervals. In this case, it's 5. 11 minus 1, 10. 10 divided by 5, 2. So h is 2 times y0. What is y0? This is 0.0. This is 0.1. This is 0.2. This is 0.3. This is 0.4. And this is 0.5. Remember, you have to start from 0.0, not 0.1. So 2 y0 plus the y value of the last point, which is y5, plus 2 times of y1, y2, y3, and y4. That's it. Let's go and substitute the values. So we know that h equals to 2 in this question. 2 divided by 2 times, what is y0? Y0 is, the y value of 0.0 is 1 to the power of 3. The y value of the last point is 11 to the power of 3 plus 2 times of 3 to the power of 3, 5 to the power of 3, 7 to the power of 3, and 9 to the power of 3. That's it. Let's go and put it into the calculator. Well, 2 divided by 2 is 1, so I don't want to put it. Or maybe we can put it just to make sure we are putting everything into the question. So control division 2 times parenthesis 1 to the power of 3, which is 1 obviously, plus 11 to the power of 3, plus 2 times of 3 to the power of 3, plus 5 times to the power of 3, plus 7 to the power of 3, plus 9 to the power of 3. Okay, press enter. 3780. As you can see, this time your value is much closer to the exact value. 3780. Can we find the percentage error? Percentage error in this case is 3780 minus 3660 divided by 3660 times 100. Okay, and definitely the percentage error is going to be less than the previous time. 3680 was it? Let me see. 780. 780. We're gonna go for press Control Enter to have it in decimal. 3.28 is the percentage error. 28. Okay, remember, again, you can have the table instead of having the function. What does it mean? They can give you the table x, y, 1, 3, 5, 7, 9, 11. 1 to the power of 3, 27, 5 to the power of 3, 7 to the power of 3, 9 to the power of 3, and 11 to the power of 3. Okay, so they can give you the table. Even if you, in this case, it's literally, again, the same. You have to go and find the area between this section the second area, the second area, the third, fourth, and fifth area, okay? In this case, however, since the subintervals are the same, you can use trapezoidal rule, because the subintervals, trapezoidal rule, which you have in your formula booklet, because subintervals are the same. So when you have a question like this, first of all, you're going to ask yourself, do I have equal subintervals or not? Because it's going to make a difference. Thank you so much for watching this video.